Okay, so saya sudah start recording. Alright. So let me. Okay. Good. So okay. So now we start with 8.3 lah. Yeah, heat conduction. Okay. Before we have all of us already learned 8.1, which is stress and strain. Okay, and then we also learn about Young modulus. Okay, but not yet finished about 8 point, maybe 8.1 or 8.2, not yet finished. So because all of us involved, all the classes involved today, okay, so I just straight away start with something new lah. Okay, something new, which is 8.3 heat conduction. Okay, our UPS 3 is chapter 7 and chapter 8. So I can say 8.3 and 8.4 is the final part lah, final part for this UPS 3. Okay, so pay attention lah, yeah, pay your serious attention. Okay, so 8.3 heat conduction. All right, so I just double check. Yeah, I'm recording. So yeah, we're going to learn about heat conduction. Okay, heat conduction, we know that we have, how the heat transfer. Heat transfer by three means. Yeah, heat transfer by three means. I believe all of you learn about this. First way is by conduction, and then we also heat also transfer by convection. This happen in the liquid or gas. Yeah, heat transfer also by radiation. Radiation normally is for the sun lah, sunlight, sunlight radiation. So there are three ways of heat transfer, but for our syllabus, metric syllabus, we only learn one. Yeah, we only learn heat conduction. Okay, let me adjust a little bit. Okay, so somebody, all right. Okay, yeah. Yeah, I believe all of you are here. So our syllabus is only focused on conduction lah. Yeah, we don't learn about convection and radiation. That one you will learn in university lah. Yeah, university. Okay. So heat conduction, okay, normally here happen in the solid. Yeah, solid. Heat conduction. Especially like, for example, you are frying using the frying pan, then you can feel the heat conduction lah. Or you use the water kettle, you can feel the heat transfer by conduction. Yeah, you feel everything is hot, right? All those are conduction. Okay, so so heat transfer, yeah, rate of heat transfer, okay, through always heat transfer from hot medium to cold medium. Okay, okay, I will explain this one later. So this is the equation. Rate of heat flow is equal to negative Ka delta T over L. Okay, I will write this. I found it easier to explain using OneNote lah, something I write out. Yeah. Okay, so our chapter now is 8.3 heat conduction. Okay, 8.3 heat conduction. Right now also I feel I'm warming up. I need time to warming up to teach. So I need heat conduction right now. Okay, so rate heat conduction based on this formula. Okay, Q over T equal to negative Ka delta T over delta X. Is it using delta X? Oh, using L, sorry. Yeah, last time used delta X, but here using L. Okay. Actually, if you look at my video, okay, my previous video, my formula is D. Alright, I have to adjust the thickness, sorry. Okay, if you look at my video, I use dq over dt negative Ka delta T over delta X lah. If you look at my YouTube channel, okay, this is the symbol that I used. Okay, So it's the same formula. It's the same formula. Just that we have to change the. Somebody is coming in. All right, I admit already. Yeah. Okay, so I just have to change to this unit Q over T because our new syllabus. Yeah, because of our new syllabus, I have to change the symbol. But they mean the same thing. Yeah, they mean the same thing. So you also have to adjust lah. Yeah, you watch my video, you saw different symbol. You have to change to the new symbol lah. Yeah, referring to the lecture note. Okay, just refer to the lecture note. So delta x is actually L lah. Yeah, dq dt is the same as Q over T. All right. Okay. Yeah, all of you using not using MOE email. That's why I have to. Yeah, if you use MOE email, I don't have to admit you. Yeah, into the room. If you are using personal email, then I have to admit. Yeah, that's why. Yeah, of course. Never mind. Okay. So. What is all this symbol? Okay, Q over T is actually rate of heat flow. Rate of heat flow. Okay. If you look at the formula, it is joule per second, right? It is like energy over time. Energy over time. So actually, this is the same as power. Yeah, actually it is the same as power because it's energy over time. Rate of heat flow actually is the same as power. So the unit of rate of heat flow actually is joule per second, or you can write as watt. Watt. Yeah, joule per second, watt. Okay. So Q over T is rate of heat flow. Now how about K? K is called the thermoconductivity. Thermoconductivity. Sorry, not thermo. It's thermal conductivity. Yeah. Thermal conductivity. Thermal conductivity. And what's the unit for thermal conductivity? What's the unit for thermal conductivity? Later we will work it out. What's the unit for thermal conductivity? Okay, well, what is thermal conductivity? What I can say is thermal conductivity is depend on thermal conductivity depends on what? Depends on material. Type of material. Remember what kind of quantity in 8.1 or 8.2 depend on material? Yeah, in stress and strain, what quantity we learn that depend on material also? Remember? Yeah. Anybody? What quantity we learn? Yeah, in stress and strain that depend on type of material. Yeah. Can you listen? Young modulus. That's right. Good. Ryan, thank you. Young modulus. Yeah. Why so quiet this room? Oh yes, force constant. That's right. So before this, we have learned about Young's. Okay, this one, Young modulus, which is stress over strain, right? And we also learned about the force constant, which is force over delta L. These two, the Y and K, also depends on material. Depends on type of material. In fact, they are actually how how tough is the material. It's the rigidity. It's a measure of rigidity of material. Rigidity of the material. So this one depends on material. So we have Young modulus for steel. We have Young's modulus for copper. We also have K for iron, like that. Yeah, they all of them have different value. Okay, so this thermal conductivity also the same. Class also the same. We have K for let me think. Yeah, K for K for copper. We have K for aluminium, steel. But for me, I'm not sure which one can conduct heat more easily. So what is thermal conductivity, class? What I give the answer already. What is actually thermal conductivity? What is thermal conductivity? If before this we learn about Young modulus and force constant, they are like referring to the rigidity of material. How tough is the material? If thermal conductivity, can you guess? Can you guess what is the function of thermal conductivity? Got answer? What's the function of thermal conductivity? Yeah, as the word suggests, thermal conductivity. What is thermal? What is the word thermal means? Do you understand what is thermal? Thermostat, thermal. When do you hear about thermal? Thermal means heat lah. Heat. Yeah, thermal is heat lah. Temperature. Yeah, temperature is like a measure of how the hotness, right? So conductivity means what? Conduct the heat lah. Understand? Transfer the heat. How you transfer the heat through the solid. So what is mean by thermal conductivity? It means how well the material conduct heat. Understand or not? Maybe copper conduct heat better than steel. I'm not sure lah. Actually, I'm not sure which one conduct heat more easily. You have to check Google. You have to Google it lah, Wikipedia, to find out which type of metal conduct heat more easily. So it is what? It is a measure of what? It is a measure of how well it conduct heat. How well it conduct heat. How well different material conduct heat more easily. Okay, some material become hot very fast. Some material, I can say is, I give one good example lah. The thermal conductivity of steel, of course, is bigger, faster than glass. Glass is a bad conductor of heat. Steel is a good conductor of heat. So it's all depend. What? K lah. K. Yeah, class, don't mix up. The K over here is called thermal conductivity, but K over here is called force constant. They use the same symbol but different meaning. In fact, K, they use in many contexts, use in many topic, but with different meaning. Don't get confused, class. Yeah, K over here is called force constant. Force constant. Yeah, it's rigidity of material. But K over here is called thermal conductivity. They still use the same symbol, but different meaning, different context. So this K over here is thermal conductivity. That means how well it conduct heat. Yeah, like glass is a bad conductor, steel is a good conductor. Yeah, not only here. Here is force constant. Yeah, K also used in, K used in what? Boltzmann constant. K also equal to Boltzmann constant, but you haven't learned about this one. This one you learn. You learn in is it Boltzmann constant or Planck? Boltzmann constant. Boltzmann constant. This one you learn in Sem 2 lah. Not now lah. Yeah, this one you learn in Sem 2. So K also known as Boltzmann constant. But this one you learn in Sem 2, not now. Okay. So K got used in three places: thermal conductivity, or force constant, or Boltzmann constant. Okay, so be careful, class. Understand? Okay, and then how about this one? Okay, unit. What is the unit for K? Later I will explain. Yeah, how to get the unit of K. I don't want to tell you straight away. A is the cross-sectional area lah. Yeah, A is the cross-sectional area. A is the cross-sectional area. And then what is delta T? Cross-sectional area, what's the unit? Unit for cross-sectional area, of course, is meter square lah, if SI unit lah. Okay. And then, what is delta T over L? What is delta T over L? Delta T over L is called temperature gradient. Temperature gradient. You know? Temperature gradient. Temperature gradient. Later I will tell you what is temperature gradient. You can, it's like a slope lah, a gradient lah. As the name suggests, it's a gradient. But gradient of what? Of course, it got referred to a graph lah. Yeah, somebody speaking? Yes, somebody speaking? Siapa yang cakap? Saya kena mute kan dia. Mute. Oh, sorry. Okay, thank you. Yeah. Okay, so temperature gradient. That means, as the name suggests, is actually gradient. Yes, it is a gradient, but gradient of what? So if somebody is a gradient, means it refers to a graph. A graph of what? As the symbol suggests, it is the gradient of temperature against length. Gradient of graph. Graph of what? Graph of temperature versus length or distance. Okay. So later I will explain about this graph. Okay, class. Okay, look at what is the unit for temperature gradient first. Yeah? Temperature gradient unit is what? Okay, for SI unit for temperature is what? SI unit for temperature. Remember, class? SI unit for temperature? Do you remember Kelvin? Yes, Kelvin. Kelvin. But this is the change of temperature. Change of temperature. Okay. If SI unit for temperature is Kelvin, but talking about change of temperature, it can be Kelvin or degree Celsius. Yeah. Why I say like that, class? Why I say like that? This is change of temperature. Change of temperature. Let me write it out. Change of temperature. Delta T is change of temperature. T is temperature lah. T is temperature. Okay. Now, class. Now, look at here. Temperature of, let's say, 0 degrees Celsius. Okay. 0 degrees Celsius. Change it to Kelvin, class. Change it to Kelvin. How to change to Kelvin? Plus 273. Correct or not, class? Plus 273. So 0 degrees Celsius is 273 Kelvin. Okay. Now, how about, let's say temperature 1 is 0 degrees Celsius. How about temperature 2? Temperature 2 is 1 degree Celsius. What is 1 degree Celsius in Kelvin? How do you change? Also plus 273. Right? So you get 274 Kelvin. Okay? Now I want to ask you, what? Let's say temperature 1 change to temperature 2. Yeah? Temperature 1 change to temperature 2. What is the change of temperature? Okay, let's say this is the initial temperature, this is the final temperature. Okay, can you calculate the change of temperature from 0 degrees Celsius to 1 degree Celsius? What's the change of temperature? What is the change of temperature? Very simple question. What is the change of temperature? We just take final temperature minus initial temperature, right? 1 degree Celsius. Correct or not? 1 degree Celsius. Just take final minus initial. 1 minus 0 is 1 degree Celsius. Now, how about change of temperature in Kelvin? We also take 274 minus 273. So how many Kelvin is this? How many Kelvin How many Kelvin is the change of temperature? Also 1 Kelvin. Correct or not, class? Okay. Let's say, from 0 degrees Celsius change to 10 degrees Celsius. So this is actually 0 degrees Celsius 273 Kelvin. This one is 283 Kelvin. So what's the change of temperature, class? What is the change of temperature over here? What is the change of temperature here? Change of temperature over here is 10 degrees Celsius, right? Final minus initial. What is the change of temperature in Kelvin? Change of temperature in Kelvin? 10 Kelvin also, right? So that's why what I want to say is, what I'm trying to say over here is, this is the, let's say this is the initial temperature, this is the final temperature lah. What I'm trying to say is, the change of temperature of 1 degree Celsius is the same as change of temperature of 1 Kelvin. Yeah, change of temperature of 10 degrees Celsius is the same as change of temperature in 10 Kelvin. So for change of temperature, it can be have 2 units. You can either put it in degrees Celsius or Kelvin because the value is the same. The value is the same. 10, 10, 1, 1. So the unit you can, for change of temperature, you can either put degrees Celsius or Kelvin. Understand? The increase of 1 degree Celsius is the same as increase of 1 Kelvin. So what I want to say is the SI unit for temperature only Kelvin, but if change of temperature you can either put degrees Celsius or Kelvin, because 10 degrees Celsius is the same as the change of 10 degrees Celsius is the same as change of 10 Kelvin. It's the same. Yeah. So you can put either unit. So what I want to say over here, the temperature gradient here, what's the unit? What's the unit? For the top, you can either put Kelvin or degrees Celsius. The below length is meter. So temperature gradient, the unit is Kelvin per meter, or you can write as degrees Celsius per meter. Understand, class? Okay. So all this unit very important lah. Yeah. Change of temperature, you can either put Kelvin or degrees Celsius, because 1 degree Celsius is the same as 1 Kelvin. 10 degrees Celsius or is the same as 10 Kelvin. Yeah. Increase of 10 degrees Celsius is the same as increase of 10 Kelvin. As simple as that. Okay. Now, what's the unit for thermal conductivity? Maybe some question will ask. Maybe sometimes the question will ask you to find the thermal conductivity of certain material. You will ask. So we know that final answer you must have answer and unit. If you don't give unit, you are wrong, isn't it? So no matter how, we must know the unit of thermal conductivity. Anyone here know the unit for thermal conductivity? You know? Anyone here know? Tell you the truth, I also don't know. So I have to find it out. How do I find it out? I must have a method. How to method? Let's say how to find the unit for thermal conductivity. Just use the formula. We know the unit for other quantity like rate of heat flow, like area, like temperature gradient. We know the unit already, right? So finding the unit for thermal conductivity, not a problem, right? Not a problem. Okay, let's find it out. Yeah, let's find it out. Okay, write the formula again. Write many times, never mind. The more we write, the more we remember. Okay, so what's the unit for rate of heat flow? Rate of heat flow is, as the name suggests, rate is like time. Yeah, heat is like, rate is like a time. Heat is like, energy, right? Energy. So energy over time is joule per second is watt. Okay, so this is watt. Yeah, rate of heat flow is watt. This one is meter square. Area is meter square, and temperature gradient is Kelvin per meter. So what's the unit for K? It's easy lah, kan? So the unit for K, let me unit of thermal conductivity is, so all the rest go to the other side, right or not? Divide. So it become what? Become what? Watt per meter square. Let me write out. Watt per meter square, and then Kelvin per meter. So okay, so what they give you? So watt per, so this meter square -1, so meter lah. So it become 2 minus 1 become m only. Kan? Betul tak? 2 minus 1, get this one. The unit for K is per meter per Kelvin. That's the unit for K, thermal conductivity unit. Watt per meter per Kelvin. Understand? You must know how to find the unit using the formula. Okay, good. Now let me explain what's the meaning of this symbol, this formula. Okay, this is Q over T is rate of heat flow, then thermal conductivity, and cross-sectional area, temperature gradient. Okay, like this. So let's say I have let me see. Let's say you have here you have hot water, hot water. You boil it, boil it really. With 100 degrees Celsius. So it's hot. Okay, so it's hot water bath over here. Yeah, and then maybe I don't know how you I don't know, like just a hot sauce. Yeah, and then let's say there's a metal rod here. And then I don't know how you connect with the the metal rod with the hot water, but just connect here. And then here there is ice, ice. Ice is cold, right? Ice is cold. Okay, so cold, it is 0 degrees Celsius. Okay, 0 degrees Celsius. This 100 degrees Celsius, very hot. Okay, and this is the metal rod. So what happened, class? Yeah, what happened? The heat will start to flow from hot to cold, isn't it? Heat always flow from which direction? Is it hot to cold or cold to hot? Heat flow from hot to cold or cold to hot? Class? Hot to cold. That's right. Very good. Yeah. Heat always flow from hot to cold. Okay. Remember that. That's a very important. Heat flow. Yeah. How to write? Heat. Heat flows. Always flow from hot to cold. So got energy. Got heat energy flow from hot to cold. So based on this formula, rate of heat flow, let me write it out. Q over T equal to negative Ka delta T over delta over length, over distance. Okay. So how to explain this formula, class? How to explain this formula? So K is what again? K is thermal conductivity. It depends on type of material. Yeah, type of material. So how well it conduct heat. Yeah, how well it conduct the the heat, the Q. How well it conduct the heat. Heat is the Q lah. So that means in simple word, what I can say is there are more heat flow. The heat flow will increase. Yeah, the heat flow will increase. That means the Q, the energy, the heat, will flow from hot to cold. If this metal rod is a good conductor, If the K value very high, a good conductor. If it is a good conductor, so a lot of heat will flow from hot to cold. If it's a good conductor. So kalau K, kalau you have a big K, then you have a big heat flow. Also, if you have a big cross-sectional area, also more heat flow. Understand or not? I want to ask you, class. Very simple. You have a small rod, a thin rod, compared to a large cross-sectional area rod. A1 and A2. Which one conduct more heat? Which one conduct more heat faster? I can say faster. Which one conduct heat faster? The big cross-sectional area, or small cross-sectional area? Which one conduct heat faster? Yeah? Hello? Which one conduct heat faster? Yeah, of course A2. Yes, A2. Because you conduct more heat lah, faster, right? Not? So the bigger the bigger the rate of heat flow. Correct or not? Conduct heat faster. If a thin one, macam longkang lah kan, longkang besar, banyak air lalu. Kalau longkang kecil, sikit saja air, macam tu lah. So more area, more heat flow. Okay, and then what is delta T over L? What is delta T over L? You understand this one? Delta E over L? Like this. Very simple. The temperature gradient. Delta T over L is called temperature gradient. So what is temperature gradient? How to find delta T? How to find delta T, class? How to find delta T? Delta T is change of temperature between the change of temperature between these two ends. What is the change of temperature? Delta T over here. What is delta T? What is delta T over here? What's the change of temperature? So we know that heat flow from hot to cold, isn't it? So heat start from where? Heat start from where? Heat start from hot. So this is, we call it initial point, and then heat flow from hot to cold. That means cold is the final point. Heat always flow from hot to cold. So delta T is, we can take the hot one as initial temperature. This is the initial temperature. This cold is the final temperature. Understand, class? Cold is the final temperature. So what is the change of temperature between these two ends? Just take final minus initial lah. Final minus initial temperature. So what is final is 0 degrees Celsius minus 100 degrees Celsius is what? Negative 100 degrees Celsius. So that's the change of temperature. Understand or not? Change of temperature, this value is always negative. This change of temperature is always negative value. Is always negative value. Because why negative? Delta T is always negative value? Because we always take the cold minus the hot. Why we must take cold minus the hot? Because cold temperature is the final. Why we say cold is the final? Because heat never flow from cold to hot. Heat comes from the hot source. Heat comes from the hot source. Heat always flow from hot to cold. Understand? So cold is the final temperature. Hot is the initial temperature. So we always take the low temperature minus the high temperature. Understand? Delta T always take the, you repeat with me. Yeah, you repeat in your heart. Your word, your mouth move with my mouth. Yeah. So it's a low temperature, always low temperature minus the high temperature. Understand or not? It's always the low temperature minus the high temperature. So that's why Because low minus high temperature, that's why we always get negative value. So remember, delta T is always negative. Can you repeat? I cannot hear your sound, but I can imagine that you are speaking with me. So delta T is always negative. Understand? Length. What is length, class? What is length? Length is the distance between these 2 points, between this hot and cold. So that is the distance between them. Distance between them. That is L. Understand? Distance between the hot end and the cold end. That's L. Delta T means between these 2 points also. We find the difference in their temperature. And then this is the distance between the 2 temperature point. That's L. Understand? So I want to ask you. I'm not asking. Yeah, I'm teaching. Yeah. Okay. How is it a question? I'm not. I don't. Yeah, it's a question. It's a question. Yeah. Maybe this is a question. Yeah. Let's say I have another one. This is from 100 to 0. I want you to compare. Now this is the question. I want to compare. This is from 100 to 0. What if I have another example? What if another example? Let's say I have maybe this temperature initial is just 40 degrees Celsius. 40 degrees Celsius water. To transfer the heat through a metal rod to another, source of water with just, final temperature should be a bit colder lah, a bit colder temperature. Maybe it's just 30 degrees Celsius, warm water. Okay, warm water. So now I want to ask you, class, what is the temperature gradient? You compare this 100 to 0 and 40 to 30. What's the difference in their temperature gradient? Okay, maybe I should draw a graph. Yeah, maybe I should draw a graph, right? I should draw a graph, then you can see clearer. Yeah, this one just bring it to other side. Okay, maybe I should draw a graph. Yeah, compare here and this one. Okay, so maybe I should draw a graph lah. Yeah, draw a graph, then you can see clearer between these two. Temperature gradient. So last time I talked about temperature gradient. Gradient means you refer to a graph. You must have a graph of temperature against distance. So for this example, I can make a graph. Yeah, I can make a graph. I can make a graph of let me make a graph. Okay. Temperature against L lah. Temperature against L. So I can draw a graph from hot to cold. From hot to cold, that means this is the first point. Starting from initial is zero distance, and then moving to, I don't know, maybe it's 1 meter. Maybe it's 1 meter distance. This is here is 1 meter lah. Or this is L lah. This is L. So I can make a graph. This one is 100 degrees Celsius. 100 degrees Celsius. This the degrees Celsius, and the if become until here the final is cold temperature. This one is 0 degrees Celsius. Okay, 0 degrees Celsius. So the temperature, the graph actually is like this. The temperature actually drop. Drop from hot. The temperature actually dropped from hot to cold. Cold, I should use blue color lah. Yeah, more realistic. Yeah, cold. So I can make a graph of temperature against distance. Temperature against distance. So this is in meter. So what is temperature gradient, class? What is temperature gradient? Temperature gradient. Temperature gradient is the gradient of this graph lah. Delta T over L. That's the grade. That's excuse me. So that's the temperature gradient. That's the delta T over L, the gradient of this graph. And temperature gradient is always negative. Yeah, temperature gradient temperature gradient, delta T over L, yeah, delta, let me write out, delta T over L, always negative value. Remember that, this is important, delta T over L is always negative, delta T over L is always negative, because it's a negative gradient. Negative gradient, you know why negative? Tell me, why negative? Because the gradient is negative ma. The gradient is negative ma, because it always high temperature flow to low temperature. Because we always final minus initial temperature, low temperature minus high temperature, you get negative value. Delta T is negative. Negative divide by the length, you get a negative value. So temperature gradient is always negative. Understand, class? Understand? Give me a thumbs up if you understand. Okay. Thank you. Yeah, thank you. So, now you see. So temperature gradient is always negative. Remember, temperature gradient always negative. UPS. You remember this for your UPS. After that, you can forget lah. Just kidding. Okay. Okay. So how about now? How about this one is from 100 to 0. But how about 40 to 30? 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 How does the temperature gradient looks like? More gradient or less gradient if compared to 100 to 0? Compare with 40 to 30. Which one has more gradient? Which one do you think has more gradient? Okay. Which one do you think has more gradient? Think logically. Think logically. Physics is logic. Okay. Which one has more gradient? Speak with your you just think, picture it. So this is 40 to 30. So it's, excuse me. So it's 40 to 30. 40 degrees Celsius to only 30 degrees Celsius. Not much difference, right? From what is this? 0 to 30. So 40 to maybe this length or 1 meter or so. Okay, 30 is over here. So what is the gradient? Gradient is like that only. Still negative gradient. But less gradient, isn't it, class? This one, delta T over L. This one still negative. Negative gradient because it's still, negative gradient lah. Okay, I just want to ask you, which one has more gradient? Which one has more gradient? The first one or second one? Of course, it's the first one, more gradient. This one less gradient, isn't it, class? So what happened? Why so big deal with this? Big gradient and small gradient. Why is the big deal for this equation? Where's the equation just now? Where's my equation? What is the big deal for this equation? Let me take it out. Let me take it out. Yeah, let me take it out. Make it bigger. Okay. Okay. What's the big deal? Big gradient and small gradient. What's the big deal for rate of heat flow? Just now we know that a good conductor, more heat flow. More area, more heat flow. More gradient. Class, repeat with me. More gradient. More gradient. Like this one. More gradient compared to small gradient. Which one more heat flow? Which one more heat flow? Of course, this one, because the difference in temperature is so high. The difference in temperature is so big, right or not? 100 to 0. Of course, there's a lot of heat flow. Comparing to only between 40 to 30. Almost same temperature. Almost same temperature, so there's less heat flow. Less heat flow, guys. Because this gradient is bigger compared to this one, this small gradient. So if bigger gradient, more heat flow. Understand, guys? Understand, girls also? Understand? Good. All of you understand. That's the way. So more gradient, more good conductor. Yeah, good conductor. What I can suggest is the big area, big area, big area. What I can write, a big area made of maybe copper, aluminium, good conductor, and then you make it maybe big temperature gradient, 100 degrees Celsius to 0 degrees Celsius, a big gradient, temperature gradient, delta T over L, delta T over L. So you have a big gradient also. So there'll be a lot of heat flow. A lot of heat flow. The rate of heat flow is also high. Begitulah conduction, very easy. Okay. Now class. Now, what is mean by why this equation has a negative sign over here? Why the equation has a negative sign over here? Why? Yeah? Why? There is a negative sign over there. Why there is a negative sign over there? Why there is a negative? Why there is a negative sign over here? Look at the notes. What it says. What is mean by negative sign? I see the temperature gradient is degrees Celsius per meter or Kelvin per meter, right? I said already. The change of temperature can either in degrees Celsius or Kelvin. Yeah. Rate of heat flow is joule per second or watt. All this. This one. See this one? The negative sign indicates that heat flow is always in the direction of decreasing temperature. You understand? You don't understand, you read the second time. Heat flow is always in the direction of what? In the direction of increasing temperature or decreasing temperature. What is mean by in the direction of decreasing temperature? That means in the direction of hot to cold. In the direction of hot to cold. In the direction of decreasing temperature. Understand or not? What I said just now lah. The heat always flow, never flow from cold to hot. Heat always flow from hot to cold. So that the heat will flow until both ends has the same temperature. They become same temperature. As long as they have two ends with different temperature, the heat will start flow. If both ends have the same temperature already, no more heat flow. Understand? No more heat flow. So the heat flow will stop. The net heat flow will stop. The heat only start to flow when there is a difference in temperature, delta T. If the delta T is become 0 already, that means they have the same temperature at both end. So then the heat will not flow. The rate of heat flow is 0. If delta T is 0, the rate of heat flow also 0. No heat flow. So there's for heat to flow, there must be a difference in temperature. Barulah heat can flow. Yeah, you must have hot and cold end. One higher temperature, one lower temperature. Only the heat will start flow. If the difference in temperature is very big, then the heat will flow a lot very faster compared to difference temperature in very small difference in temperature. You must have a difference in temperature, only the heat will start flow. And heat always flow in the direction of decreasing temperature. Heat always flow in the direction of decreasing temperature. That means heat always flow from high temperature to low temperature. That's the meaning of negative sign. That's the meaning of this negative sign. That's the meaning of this negative sign. What is mean by this negative sign? What's mean of this negative sign? Heat flow from hot to cold. Okay, why do you need, okay, I almost finished today's lesson, yeah, almost finished. Why do you need, why do you need the negative sign? Yes, I know that this negative sign means heat flow from hot to cold, heat flow from in the direction of decreasing temperature. But why do you need this negative sign? Logic also, understand? Class, physics is logic. You know why? Because the temperature gradient is negative. As I said, delta T over L is a negative value. Delta T over L is negative value. So this delta T over L is a negative value. So you need another negative. Then only Q over T is positive. Understand or not? You see, uh, Q over T equal to negative Ka delta T over L. It means that this one is negative, yeah, negative. Ka delta T over L. Delta T over L is also a negative value. Yeah, is the negative value. So negative, negative, you get positive. Yeah, positive. So this Q over T must be positive value. Must be positive. Yeah, must be positive. Must be positive. Rate of heat flow must be positive value. So in order to get rate of heat flow positive value, so here you must have a negative value. You must have a negative sign. Barulah negative times negative get positive. So this negative also means it also means the delta T over L is a negative sign. You understand that? Ini negatif sebab dia tahu negatif delta T over L ialah negatif dan delta T over L ialah negatif sebab kenapa? Sebab heat always flow from hot to cold. Because we take the low temperature, final temperature is cold minus the initial temperature hot. That's why we get a negative delta T. Delta T kita ialah negatif. Delta T kita negatif. So that's why delta T over L kita negatif. Dan that's why formula kita mestilah ada negative sign di sini supaya lah negatif baru dapat positif for our Q over T. So ini maksudnya, ini pun bermaksud dia tahu negatif di sini pun tahu delta T over L di sini ialah negative value. Delta T over L ini negative value means the heat is flowing from hot to cold. Itu maksudnya lah. Kamu faham tak? Saya tak tahu you get what I mean or not. Yeah? Okay. Yeah. You think for your think again lah. After this you think again. So I think that's today's lesson lah. Yeah, that's today's lesson. At least you understand what is this formula about. Yeah, what is this formula about? Yeah. So yeah. Thermal conductivity is a property of conducting material where good conductor will have higher value of K compared to poor conductor. So K macam Young modulus depend on material. Got good conductor material, got bad conductor material. The unit for K is watt per meter per degree Celsius or watt per meter per Kelvin. Kalau you guna delta T tadi guna degree Celsius, you akan dapat per degree Celsius lah. Kalau you guna Kelvin, you dapat per Kelvin lah. Macam mana dapat unit ni? Saya sudah tunjuk you kan. You just have to rearrange the formula to get the unit. So this one can also be, you can also, kalau you can also write as watt per meter per degree Celsius. Kalau you guna per degree Celsius lah, as I said just now, delta T tadi boleh jadi degree Celsius atau Kelvin. Begitu. That's why dia ada per degree Celsius juga. Ini UPS lah kelas, UPS. So see delta T O L is low minus high because it's final minus initial. Final is always low temperature because heat always flow from high to low. Heat always flow in the direction of decreasing temperature. Itu dia. Okay, low to high. Okay, temperature inilah dia. Ini graph nanti saya akan explain lagi ya. Saya ada explain sikit Actually this insulated, non-insulated nanti saya akan explain lah. Nanti ini pun saya akan explain nanti. Okay, so that's today's lesson. Boleh faham? Ya? Okay, 1 jam cukup lah. Saya banyak bercakap-cakap ni. Okay, so I think that's all for today. Good night. Thank you. Tomorrow I will start with bagi kelas yang sudah habis, saya akan continue lah dari sini. Yang belum habis 8.1, 8.2, saya akan continue 8.1, 8.2 lah. Okay, good night everyone. Have a good night sleep and prepare for your UPS 3. That's your harapan. Okay.
Thank you, sir.
Thank you, sir.
Okay, I will post this to
Thank you, sir.
later. Okay.
Thank you, sir.